Hey, welcome to the Crazy Hat Chemist. So here we go. Stoichiometry and dimensional analysis still. We're doing part 8.3 here. That is stoichiometry with balanced equations. So let's get going. Bam! Okay, so our third problem here, 0.345 grams of 3-hexyne, that actually has a triple bond in it. A liquid is burned to completion. How many grams of liquid product is produced? So, our flow chart, like always, that's our warm blanket, if we will. So, the 3-hexyne is burned to completion. So the other reactant is molecular oxygen, and that's O2, that's a gas. There's a delta above that arrow. So what type of reaction is this? That is correct. That is a combustion type of reaction. So now what I want you to do is I want you to pause the video. I want you to write the two products of any complete combustion reaction where you start off with a hydrocarbon and the 3-hexyne is a hydrocarbon. You're going to write the two products. You're going to write their states of matter. Then you're going to balance it. You're going to balance it in this order. Carbons, then hydrogens, then oxygens. Don't forget about those fractional coefficients. I want whole number coefficients for my balanced equation. So pause that video and then balance it. And then when you are balanced it, then restart it again. So here we go. Restarting. Bam! Here's our balanced equation here. Hopefully that makes sense for you. Any complete combustion, you get carbon dioxide and water as your products. You first balance the carbons. You're going to put a 6 in front of the carbon dioxide. Then you're going to put a 5 in front of the water for the hydrogens. Then you're going to count up the number of oxygens both in the carbon dioxide and in the water, and you're going to find out that you have 17 of them over there, and then you're going to try 17 halves in front of the molecular oxygen. Once you have 17 halves in front of the molecular oxygen, it is balanced. But now you need to multiply everything, the entire equation, by 2. And that's why you get 2, 17, 12, and 10 for your stoichiometric coefficients. All right, so let's look at that flow chart and figure out where we are. We have 0.345 grams of hexyne. That's where we're starting. What do we want? We want how many grams of liquid product. So look at those two products, figure out which one is the liquid, and it is, of course, the water. So I'm going to go from the 3-hexyne to the water. Then our flow chart, okay, just as a visual map, I'm starting off with a mass. And that's mass of 3-hexyne. Then I'm going to go to moles of hexyne, using the molar mass of hexyne. Then I'm going to use a mole ratio to go from the hexyne to the water. That's a 2 to 10 mole ratio, or 10 to 2. You're going to have to figure that out. Okay? Then, once I have moles of water, then I'm going to go back to mass, but this is going to be mass of water using the molar mass of water. So now what I want you to do is I want you to pause the video one more time. Okay, pause the video and I want you to write out that whole stoichiometric sequence there. Number, units, formula. You are starting off with 0.345 grams of C6H10. Okay, pause it, then restart it. Restarting, bam! This is what you should have. Okay, you should see that in this blue rectangular box is my mole ratio, and those are the stoichiometric coefficients on the 3-hexyne in the denominator, that's the 2, and the 10 in front of the moles of water. Okay, I started off with 0.345 grams of 3-hexyne, and then I'm using the molar mass of hexyne, and that is that I'm canceling out the grams of the hexyne. That's equal to 1 mole of hexyne. Now I got moles of hexyne. I'm going to cancel out the moles of the hexyne. Then I'm going to cancel out the moles of the water. And now I have grams of water, the only units and formula that I didn't cancel out. I'm going to look at my significant figures. I got 3 significant figures for my first number because leading zeros do not count. An infinite number for the 1 in front of the mole, an infinite number for the 10 in front of the mole, because again it's counting, and 4 significant figures for the molar mass of water, 5 significant figures for the molar mass of the 3-hexyne, infinite number of significant figures for the 2 in front of the moles of the 3-hexyne, and an infinite number of significant figures for the 1 in front of the moles of water. The least number of significant figures I have is 3. So I'm going to get a number in my calculator. That's my number in my calculator. I'm looking at that 4 for rounding. That is less than 5. So I'm going to chop the number. I'm going to truncate the number. And then this is what I get right here. Number, units, formula. It's rounded correctly. That's 0.378 grams H2O. I got a number, units, formula. On my answer, I got a number, units, formula in every single step. Your chemistry professor, your chemistry teacher will love it if you have number, units, formula every single time. Don't forget that. Okay? Good. So, howdy, partner. I love chemistry. Totally. I love chemistry. Chemistry is super cool. So, that was 8.3 of stoichiometry with balance equations. And wait for 8.4. I can't wait, neither can you. Howdy, partner.